Puppet is used at Bulletproof Networks. Enjoy!
Okay, good afternoon everyone. Can you all hear me okay? Yep, perfect. Okay. So I'm going to be talking about islands, which sounds a little bit weird, but you'll see why in a second. So who am I? Who's this person that's standing up here is going to be talking to you for the next 40 minutes? My name is Lindsay Holmwood. My Twitter handle is Oxesis. I am an engineering manager at this company called Bulletproof Networks. We're a managed hosting provider based out of Sydney, Australia. You might know me from some of these projects, Cucumber and Adios, which I originally wrote, Visage, and Flapjack. I've actually been a Puppet user since 2006, quite an early adopter. But this talk isn't really about me today. It's actually about my employer. So as I said, they're called Bulletproof Networks. They're an infrastructure as a service and managed services company, a managed hosting company based out of Sydney. We have operations in the US as well. We host some relatively high-profile customers, a lot of big corporate, a lot of government stuff. So you might be familiar with some of these, possibly. Maybe Foster's, which is terrible Australian beer. And Bulletproof has been a Puppet user since 2008. So they've been using it for a little while as well. But the use of it has really evolved quite significantly over that time and only really started using it heavily from about 2010 onwards. So we have some fairly unique challenges in the way that we need to use Puppet, and these are dictated by the way that the business operates. So firstly, we have a very strong isolation between different environments. So customers are obviously not able to talk to other customers over the network. And in fact, within some customer environments, they are unable to talk to other hosts within the same customer environment. So we have a very strong need for network segregation there. We take security very seriously. And we implement this using just VLANs and access control lists on VLANs. So pretty simple, vanilla, straightforward. But what this means for us, the implication of this is that the central Puppetmaster isn't really an option because it means that you end up having a place where you keep all of the keys, all of the information for all the different customers that you have in one place. So it's a pretty tempting target for an attacker. We can't really do that. And on top of that, we have a very thorough change control process as we host lots of government and big corporates. They care very heavily about us not breaking things and making sure that we do the right amount of due diligence on any change that we make. We need to be able to verify that. And to make it even more complex as well, we're growing incredibly rapidly. 70% growth year on year for the last 3 years. So that produces all sorts of interesting technical challenges as well. So, very simple question. How do we actually use Puppet? Well, there's not a simple answer to this simple question. We actually have 3 different ways that we use it. So the first way is with standalone systems that run all by themselves, and that's Puppet masterless. So, a checkout, a Git checkout, and then running Puppet locally on these machines. The next class where we use Puppet is for internal infrastructure. So that's managing all the services that make up the platform that we then deliver services to our customers on. And then we have just full customer environments. So we do a lot of professional services for larger customers and even sort of media-sized customers as well. We will do a lot of customization and automation of their environment. Because in a lot of cases, the customers come to us because they don't have the ops experience in-house. They don't have sysadmins, or maybe they have 1 or 2. And they're really looking for us to provide that knowledge and that experience about how to build a scalable environment on top of our infrastructure. So let's have a look at the standalone systems first, the Puppet masterless systems. One of the things that we specialize in is campaign-driven business. So if you're some sort of charity site or you're a government agency and you're putting out a press release, you'll come and host with us, and we will help you scale up to deal with the inevitable onslaught of traffic that you will get. So budget.gov.au, which is the Australian federal government budget, is hosted with us. Movember.com, which is a men's health charity where men grow moustaches and raise money for prostate cancer and male depression research. Mamma Mia as well, which is like a forum site, but it had the Australian Prime Minister on it, and we got like a couple of hours notice that this was going to happen. So we use Puppet really heavily to make sure that we keep these sites up and keep them scalable. So we use Puppet specifically for deploying these reverse proxies, and these reverse proxies are standalone. There's nothing really fancy of them. They're just plain old Nginx with a bunch of patches that we've made to them, and a fair amount of heavy customization when it comes to the actual configuration, because every site that we host is completely different. There's a fair amount of Drupal that we host, a lot of PHP, but we also host a huge amount of Windows stuff as well. So, there's lots of different variety in the apps that we're hosting, and we need to configure the proxy rules quite differently between all of them. So we use a tool called Rump for this, which maybe if you're at Puppet Camp in Amsterdam in 2011, I gave a bit of a talk about it there. So Rump was originally written to make doing Puppetmasterless Puppet on older versions of Puppet, say Puppet 0.25, a lot easier. Fortunately, in Puppet 2.6 and 2.7, they've made that a hell of a lot easier to do. So we sort of use Rump for this legacy stuff, but for the other standalone stuff that we do, we're generally doing it on Puppet 2.6 or 2.7, so Rump isn't so relevant. But if you are running a legacy environment with an older version of Puppet that you can't upgrade and you want to do standalone stuff, Rump might be of interest to you. Okay, the next class of services are our internal infrastructure. So as I was saying, it's the infrastructure that we use to build the platform on which we sell services to customers on. And this is actually pretty vanilla, pretty basic. You've probably seen this in your environment if you're using Puppet. It's a pretty common pattern that we're following here. So we have a single Puppetmaster. And we are supporting clients that are running Ubuntu, and they're either running Lucid or Precise. So whenever there's a new LTS release of Ubuntu that comes out, a long-term support release, we will upgrade to that, and we will slowly retire out the previous release. So the last case that we have is these full customer environments, and this is where things start getting a little bit tricky. Every customer has their own Puppetmaster. We have no shared infrastructure when it comes to these, and we have a lot of customers that are doing this. So every Puppetmaster only knows about itself, and it doesn't know about any other Puppetmasters, and all those other Puppetmasters don't know about it either. We have this problem that we've termed islands of Puppet, where you have these separate clusters, Puppetmaster clusters, that you're writing a whole bunch of modules and manifests for, but they don't. We have this code share problem between all of these different clusters because they're all essentially doing the same thing, but maybe doing them in a slightly different way. And this is quite an interesting problem. And the way that we have traditionally approached solving this problem is, okay, well, let's copy this thing that sort of worked over here and let's make some changes to it and push it into this other customer's environment. And that's a good way to realize that you have a problem, but it's not a nice problem to have. So yeah, this copy pastoring your Puppet code only scales so far. We end up having a lot of configuration drift between the different environments as well. And that's sort of exemplified in this particular scenario. So you have, say, an Apache module, and that's a base module that you've made for all of your customers. But then you have some customizations that you need to make for customer A. So we will make a fork of that, and then we'll make some customizations there. And then we have customer B that comes along that has a completely different set of customizations. So this is starting to get a bit scary. And then you have customer C that's like a fork of customer B. It's not a fork of the original Apache module. And then, let's add a customer D in here as well. And this just goes on and on and on. And this is a really nasty situation to be in. We don't want this at all. So we spend a lot of time focusing on the tooling and the development process for writing our modules and manifests to try and eliminate this problem. And the real problem is just having poor code share between all these different environments. You have these silos, I suppose, within silos within silos within silos. And there's useful stuff within each of those silos that we need to be able to share outside. And then you have other things that, like this, like what happens if you have a bunch of customers that come along and want to edit their edit this Puppet code that you provided them as well. So not only do we have this maintenance and management problem of just making sure that all of our engineers are following the right process, but then when we have a customer come along that also wants to contribute patches back, how do we maintain that? That's a pretty nasty problem. And what are the patterns that we can use to actually refactor and build up a common code base that we can then reuse and recompose for different customer needs. So I'll talk about that a little bit later in the talk. The good news, though, is that it's not all bad news. There are lots of commonalities between all these different environments. So firstly, we have a mix of Puppet versions, but it's a relatively small mix. So firstly, we're using 0.25 for for VMs that are provisioned a reasonably long time ago. These are considered to be legacy VMs. And then we're using Puppet 2.7 for any of the new VMs that we're provisioning for customers. And we were originally using 2.6, and then we force upgraded everybody up to 2.7. So we try and keep relatively recent on that. And given the rate of growth that we have, we actually we've ended up getting more customers on the 2.7 than on 0.25, just by adding new customers. So then 0.25 stuff will become less relevant. And then as the customers want to refresh their systems, then we'll just provision new stuff on 2.7. And then we're also using 3.0 in like a test lab for a particular customer at the moment. That's because we want the really deep and awesome Hiera integration. So that's probably where we'll be moving overall fairly soon. On top of that, we have a mix of operating systems, but again, it's not that diverse. So we've got Ubuntu Lucid and Ubuntu Precise. And then we have perhaps 30% of customers that are running Lucid on 0.25. And then about 70% of customers that are on Precise and Puppet 2.7. And then we have internal infrastructure that's all running Puppet 2.7, but it's spread across a variety of Lucid and Precise. The other thing that we really strongly focus on is making sure that we're using Passenger absolutely everywhere. The performance differences between using just Puppet out of the box with webrick and using Passenger with Apache or a Passenger in Nginx are phenomenal. If you look at even just a really simple setup where you have, say, 20 nodes connecting into a single Puppetmaster, using webrick, you would be lucky to get more than one node at a time working. With Passenger, we've had clusters of 200, 300 machines connecting simultaneously to that Puppetmaster, and they're not skipping a beat at all. So if you are running Puppet in production, which I'm guessing pretty much everyone in this room is in one way, shape, or form, and you're running webrick, leave this talk now and go and install Passenger, and you will thank me later. The other thing that we do is that we actually don't run a Puppet agent anywhere on any of our systems. We manually invoke the Puppet runs whenever we want to do a Puppet run. And the reason behind that is that the default behavior of Puppet we consider to be orthogonal to any sort of change control. So we don't want systems making changes without those changes being initiated by an engineer, or without us knowing about it. And yes, you can use the standard reporting mechanisms and whatnot, and Ohad was demoing that really well with Foreman. But in an environment where you care, I suppose, less about compliance and you care more about control, we definitely prefer not running our agents all the time. And for us, this means that all of the changes across our infrastructure are initiated by an engineer, and this perhaps sounds a little bit crazy when we have so many VMs and so many customers and a small number of engineers. But the trick is to build tools that make this very simple and very easy, so we can scale up the number of customers while not having to scale the number of people at the same time at the same rate. So one of the very simple ways that we try and do encapsulation is that we use this concept called roles, which you probably used in some way before if you're managing a relatively large Puppet code base. So if we look at an example manifest here for this particular node, it's an LVS running RIPT, which I was talking about yesterday. We've got a bunch of things that we want to do specifically on these machines. Again, because it's a firewall and it's running LVS, there are specific modules that we want to load in. But you notice up here, actually, there's this server definition. And what that is it's a common bit of Puppet code that we actually include across all of the different instances that we manage. And it looks like this. It's installing MOTD, Augeus, apt, utils. You can read the list there. And they're all configured as well to talk back to a central collectd instance where we're sending all of our statistics to. But we use this across all of our servers. So we have one nice simple place where we encapsulate it, and then it gets rolled out everywhere. We actually have other types of roles that are built on top of these as well. So we have ones for application servers, database servers, and it varies from environment to environment. And they basically encapsulate the behavior of that particular role. so that when it comes to defining a new node, all you have to do is pass a couple of small parameters, preferably the defaults will actually have you covered, but you pass the parameters to one of these roles here, and then the machine gets configured. So it abstracts away and encapsulates a lot of that configuration. But for us, Hiera is very much the future of where we are trying to go. In fact, the future is now. When I first gave this presentation about 6 months ago, we were just starting to dip our toe in the water. But we have some pretty good experience with it now. So who here has actually used Hiera before? Hands up. Okay, so maybe half the room. That's pretty cool. Well, this next bit is for the other half. So you've got your plain old hiera.yaml here, and you're defining the hierarchy of how information is going to be passed through to that node. So firstly, you have at the highest level, if your Hiera will try and find a file that matches the FQDN of that node in this nodes directory with a .yaml on the end of it, because as you can see down here, we're using the YAML backend. Then it'll go down to something maybe a bit more generic for that particular type of role. And then finally, you have your common, which is pretty much what we were talking before about with that server class. So for us, it was very simple to take our existing abstraction and map it into Hiera. So where we were invoking this server role, we just popped that in common.yaml, and that's now rolled out to every single machine that connects into this Puppetmaster. That's pretty cool. And then for something that's maybe a bit more specific, like this app server, we're just, again, invoking the app server role and passing a bunch of options to it. But one thing that you might notice here is it's actually a little bit ugly. And this is quite an interesting point, because we have sort of achieved what Hiera is giving us for quite a while now, using defines in Puppet. But when it comes to actually using Hiera, it perhaps doesn't map as cleanly. So the simple way of solving that in the newer versions of Puppet is with parameterized classes, and we're slowly moving all of our configuration out of defines into these parameterized classes. Defines for us are essentially dead. All the new stuff that we're doing is in these parameterized classes. Hiera also works really, really well standalone though. So I was talking before about how we're using Puppet standalone. We actually run Puppet in a standalone mode when we are bootstrapping an environment from nothing. So we'd be given a clean VM on whatever the underlying hosting infrastructure is, and we want to run Puppet standalone to build a Puppetmaster on that, so it can then serve out the manifests to all the other nodes in that environment. Hiera works exceptionally well in these sort of scenarios. So what we actually have is we have a Jenkins job that's building a custom AMI that we use across our platform every day. So on the node, when it gets booted up on EC2, we throw in this AMI.yaml here under the roles, and what this will do is it'll pre-compile all the common things that we have across all these different instances that we're providing to customers, but they take a long time. So we're using rbenv to give us these different versions of Ruby here. Now, if I were to provision a machine and compile these 3 different versions of Ruby as what's happening here with these classes, that would take a long time, especially if it's like a T1 micro. So what we do is we provision, we boot up a large instance with a huge amount with the maximum amount of CPU that we can get our hands on. Compile these versions of Ruby very quickly, and then turn it into an AMI, and then all VMs, all EC2 instances that we provision after that have all this pre-compilation here. And the awesome thing about this is happening entirely standalone, so there's no Puppetmaster whatsoever. Behind the scenes, this particular instance will git clone an entire copy of the Puppet repository, and then just do a normal agentless Puppet run, just a local Puppet run. And this just works. But the great thing about it is that you can use exactly the same definitions within the Puppetmaster. So you define once, run everywhere. Pretty cool. Okay. The other thing that maybe is slightly different to how people are doing Puppet is that we use Capistrano really heavily. So who here has heard of Capistrano before? Okay, so maybe a third of the room. So you can think of Capistrano as SSH in a parallel for loop on steroids. So it's sort of the anti-pattern that Luke was railing against when he was creating Puppet in the first place, but it provides a very convenient library and API for doing orchestration tasks just with SSH, not needing any sort of agent on a system. So the question that invariably comes up when I say this is, why are you using Capistrano and not NCollective? And that's a really, really good question. So we deploy absolutely everything across our environment using Capistrano. So we use Cap to trigger a Puppet run. We use Cap to deploy monitoring configuration, firewall configuration, web applications, and internal tools. And we don't want to treat Puppet any differently, because when new engineers come on, there is a consistent deployment tool that they can use across all of the projects. It doesn't matter whether it's configuration management, it doesn't matter whether it's monitoring config, it doesn't matter whether it's a web application. We want this principle of least surprise when they start, so that they only have to learn a single tool, and then they can take that knowledge and apply that to every other part of the business when it comes to working with our automation. And we fundamentally don't want Puppet to be any different from the rest of our stack. If we were to do this today, maybe we would use NCollective, but it's horses for courses. So how do we actually make this happen? So for simple Puppet changes, there are a couple of different ways that we use Cap when it comes to Puppet. So for simple Puppet changes, just this. So you go Cap Puppet Go, and you specify a bunch of roles that you want to run, you want to do this Puppet run against. And by default, actually, it will always include no-op mode. And again, this comes down to the principle of least surprise, right? We don't want a new engineer to come along, do a checkout of the Git repository, follow the instructions, do a Cap run, and holy crap, I've hosed all of the config across all of the servers. So when you actually want to go and apply that change, you just simply pass in apply equals true to that. Then there's a bunch of other options that you can pass to this task. So if you want to pass specific options through to the Puppet agent when it's running, you just put them in this options argument, and they'll just be passed straight through. There are a couple of other options as well to disable synchronizing Git repositories with like a Puppetmaster or skipping some tests, but I'll talk about that in a second. Okay, so on top of this, we have a bunch of smoke tests that are defined as well. So there's a little bit of talk earlier in the day about doing testing when it comes to refactoring. And we take maybe a slightly different approach in that we define very high-level tests, sort of business-level tests for the type of behavior that we expect out of these systems. So whenever you do a Puppet run, you'll get a whole bunch of Puppet output, and then it'll actually run another task afterwards, which tries to find all of the tests, all of these smoke tests that have been written for the hosts that you've just done some sort of operation over. And we try and make these really, really quick. You know, you want the smoke test to complete in under 10 seconds generally. And just very simple high-level things like, can I access Nagios and am I seeing a version string and that sort of thing. And the code behind this is sort of interesting. So what it does is it works out all of the roles that the hosts that you've just iterated over belong to, and then it runs the tests tagged with the same name. It means that you have a very fast feedback, though, on change success or change failure, because you could potentially be operating against a machine that you don't know about when you're just doing a normal Puppet run. You want to make sure that, okay, if I've made some change to a machine that I wasn't expecting, that the behavior of that machine is still retained. So the code for doing that is sort of interesting. So the first part here is that we build up an empty hash of associated roles. Then we iterate through all the roles the Cap knows about. We find all of the servers that are associated with that role, and then we stash that into this hash here. And then later on, when it comes to actually running the tests for that, we grab all of the associated roles, we unique them, and we get the tag that we want to run against, and then we just do an execution of RSpec, and we say these are the tags that we want to use. So very simple. It's just a very simple hook into Capistrano, and this just runs every single time we do a Puppet run using Cap. The other place that we're using Cap quite heavily is actually for bootstrapping environments. So what we're talking about is we're taking a VM in some sort of unknown state, and it could be something that's hosted on our infrastructure, it could be on a partner, it could be on AWS, and we want to bring it into a known state for a Puppet 2.7 run. So the way that we do this is very, very simple. We just run the simple cap task, cap no bootstrap. We pass the host that we want to run against, or maybe a group of hosts, like with roles, and it will go and implement that. It will go and run these bootstrap tasks. But there are some limitations as well with doing stuff with cap. So again, because it's SSH in a for loop, maybe the level of creativity required to do complex things can be challenging sometimes. So in like the very, very simple cases, there are reserved words that you have when you're writing your cap tasks. So run, for example, like we keep talking about Puppet runs, like I'm going to go and I'm going to do a Puppet run, but run is actually a reserved keyword, so I would love to have called that Puppet go task Puppet run, but we just sort of have to call it go. So it was a bit of a fail there. The other one is stage. So stage is an internal Capistrano keyword that's used by a couple of different plugins. So we can't use that one either. So that can be really confusing when you like define a task called stage and then cap throws some really weird error about, oh, this thing is actually already defined. So yeah, there's a little bit of a surprising learning curve there. And also singling hosts out is tricky. Cap doesn't have any real memory of what the output that it got from each of the hosts when it ran some sort of command. Now that means that reusing the data and extracting that from the remote host can require a little bit of creativity. So we happen to know Cap really well because of this. But if we look at what's actually happening here, first up we've got a list of servers, an empty list of servers, and we have a command that we're going to run. So we want to get the master status across a bunch of MySQL instances. And then we're going to run that command across all the hosts that we know about, and where we're getting some data back from whenever we run that. And then from that, we're extracting the host name, the file name, and the position from reading the data back over standard output. And then we use that we pack that data into a hash that then gets put into this array. And this is complex, right? Like it has no memory of what this information is across multiple runs. And it means that the data that you get back isn't structured either. Because you are just doing stuff with SSH, you have to know your regexes, you have to know how to manipulate strings really well in Ruby. So fortunately, we're relatively good Ruby programmers if we can do this, but it might be a bit complex if you haven't had a lot of exposure to Ruby before. So the TLDR is that there are edge cases with using cap, and they can be fun. But it does the job as well. We try and hide the complexity within another library that helps us do all of this stuff. So how do we hide that? Well, there's this little library that we use internally called Clip, written by this guy here, Aussie Linux, Mick Pollard. He maintains the Debian packages for Greylog 2 and a bunch of appliances as well. And fortunately with Clip, all of this magic is actually just abstracted away and it's reusable across all of our different islands of Puppet. So all you actually need to do is do these 3 requires here and you get all of these magical Capistrano helpers and it will just work within your environment. So that's pretty cool. We've got these 4 helpers here that all get included. So in fact, if you just do like a require clip Capistrano Puppet, it will pull in all of these. But these are actually just one small fragment of all the different tasks that we have. So we've got a bunch of different ones for bootstrapping, for general operations on nodes, and doing stuff with Puppet, plus also just deploying applications. So this is a pretty useful library that we use everywhere. So I was talking about this islands of Puppet problem earlier. And we have this copy paster problem where we don't want to just have to, whenever we're making a change for a particular environment, we don't have to copy something from a previous environment and put it into this new one. So we've tried a couple of different ways to fix this over the last 3 years. So the first iteration of solving that problem was actually just with modules. So like the Forge and Puppet module tool. So a module, you're probably familiar with this. You've got a directory and a bunch of other subdirectories under it that are expected there. And these are just all stored on GitHub. This is a directory that's stored on GitHub. And then you're using Puppet module tool to handle installing these. And we were looking at this around 2010, just after Puppet module tool had been released. So yeah, like this has actually now all been folded into Puppet itself. But if you're using an older version of Puppet, this can be useful. So we would install Puppet module. Now it's included as a face, which is pretty cool. And then within that, you would have this module file that would define, the parameters for this particular module, what the version number is, what dependencies are, what it's actually called, that sort of thing. And then we'd use Puppet module to build the module. And it turns that directory there into this tuple. So pretty simple, right? So then we would take that generated table, we would take that module that we've compiled, and we would upload it to the Puppet Forge. Sounds pretty cool. The problem with this, though, is that all of these modules are public by default. There's no way to do private modules on the Puppet Forge, so that doesn't work particularly well for us. But, yeah, like we don't want to open source all of our secret source. So the idea behind Puppet module tool is sort of interesting, though. So can we fake it? So it turns out that you can. Okay, that's running. Yeah, there we go. Okay, so we now have an API-compatible Puppet Forge right there. And this isn't difficult or complicated code. The great thing about the Puppet module tool itself being open source is that you can just reverse engineer what it's doing. So from within here, I want to say search for M. There you go, MySQL. Yeah, you even do regex matches and things like that. So this is a very simple example. So this worked out okay for us originally, but there are quite a few pain points with this sort of workflow. So firstly, there was a fairly long and complex and arduous release workflow whenever we wanted to make a simple change and roll that out everywhere. And we found that the Puppet Forge ended up being better suited for infrequent changes, like if you are trying to build a module that exposes a stable API, and it's some sort of code that's used across a platform where you don't make changes all that frequently. But we sort of don't really have that problem, like we are making changes all the time, so it wasn't really a good fit for us. It also meant that there was a higher barrier of entry for them to submit those patches, as I was talking about before, for them to do it. And we found that ended up being very, very concrete in a specific case. And that meant that when it came to sharing those bug fixes and those feature improvements, we had an amount of refactoring, and that wasn't good because we want to make that process as simple and easy as possible to contribute stuff back. And finally, we just had no real reporting. There was no central registry that you could query and say, where are all these different customers up to? Again, because we have the strong segregation between environments. So that sort of sucks. The second iteration that we looked at, which is sort of where we're at now, is using Bundler. So who here has heard of Bundler before? Okay, so a fair few people, maybe half the room. Bundler basically manages applications dependencies through a very simple text file, and it will talk to Ruby gems to suck those dependencies down and make those dependencies available to your application. So it uses this concept called a gem file, and within that gem file you have a bunch of definitions for the different gems that you want to use and particular versions, and also where you want to get those gems from. You can also group them, and that's pretty cool. So unfortunately, it was fairly RubyGem specific, but we were wondering if we could perhaps reuse this in some other way. So we had a good chat with Tim Sharp, who's Rodcheck on GitHub, and we had like a messy working prototype up and running in a couple of hours, but it was very much pre-alpha quality, and it wasn't actually something we could reliably use. So there was definitely more research required in trying to solve that problem. So then we looked at what the Chef community is actually doing to solve this problem, and they have some pretty awesome tools, turns out. So you've got Librarian, which they describe as a framework for bundlers. So you can build all sorts of different bundlers for different types of programming languages. And there's an instance of that which is Librarian Chef, which manages Chef repositories, and this was sort of the first project in the Chef world that was trying to do this. There's another tool now that most people in Chef in the Chef land are using called Bookshelf, and yeah, it does fairly similar sorts of things. But yeah, Librarian is by this guy called Jay Feldblum, and he's got some pretty interesting ideas and pretty interesting code in there. So Mick, the guy that I was talking about before, and Tim sort of sat down and did a little bit of hacking over a weekend, and they released a thing called Librarian Puppet. And Librarian Puppet's slogan is you can all stop using Git submodules now, because if anyone's used Git submodules here to manage like Puppet modules, you'll probably have a bit of an idea about the pain that's involved in doing that. So you do a gem install of Librarian Puppet, which is, the code is up over here. And this provides a bundle-like behavior for using Puppet and Puppet modules. So you have a Puppet file, sort of like a gem file, and within that you have a definition of what the forge is that you want to use. So you can use forge.puppetlabs.com, or you could use your own private forge that you've reverse engineered. Then you use to specify the modules that you want to include in the versions. And you could even include a bunch of Git repositories in here as well. So this is sort of pretty cool if you've got lots of different environments and want to have a reasonable amount of sharing between them. You can also specify ref spec itself. So if you want to use a particular version or lock a repository to a particular version, it becomes very easy to do that. And it means that you have one canonical description for that repository as to how you expect it to be configured. And your modules get installed into the modules directory, and then you git ignore them. So the Git repository doesn't know about it, but when it comes to doing a clean checkout of the repository, or every time you make a change within the repository, one of these commands gets run. So you do a librarian update, what it thinks needs to be updated, and then you just do a librarian puppet update, and we'll go and actually suck down those dependencies locally. And this has some interesting policy implications for how we start maintaining our modules. So firstly, we've sort of implemented this policy where we're always using a modules master. We're not using some weird branch off to the side. And the reason we do that is that if you end up having a branch for each customer and each customer's customizations, it becomes very difficult to integrate that. You end up having to dedicate a fair amount of time to just manage that integration, and so it's not that fun. And what that means is that we make all of our changes to the normal modules as we usually would, and then we git commit and git push those modules. But we try and make those module changes as generic as possible and try and add a bit of a wrapper around it to turn the different features that we're adding on and off. And then we have this policy that we only try and branch a module when something is super client specific. So, this is something that we will only ever do for this client, and no other client that we will ever come across will have this. Or maybe there's some sort of unmissable deadline where you just have to make a bunch of hacks to get the project over the line. And the third option is just testing ideas, so like the feature branching idea, which is very popular in the development circles. Those are the three cases that we would consider using our branches. And then we set a reminder we need to make sure to set a reminder to actually merge whatever those changes are back, because otherwise you end up with the problem of lots of disparate branches and having to try and do that integration. And then we use pull requests on GitHub for dangerous changes, like if you're fundamentally gutting the contents of a module and you're going to try and rewrite it. You want to have lots of people reviewing that. So there's been quite a few issues in maintaining Librarian Puppet because of Librarian is a pretty cool idea, but maybe it's sort of rough around the edges when it comes to handling things outside of the Chef ecosystem. So there hasn't been a lot of development done on it, on Librarian Puppet itself in the last few months, but there is this other project that actually has popped up by Adrian Thiebaud, who works at Puppet Labs in Portland. It's called R10K. And the cool thing about R10K is that it actually uses the exact same Puppet file format. So if you were previously using Librarian Puppet, or you like the idea of the Puppet file definition that I was showing just before, you can give that a go. It's very actively maintained and looking for more users, so go check that out. The GitHub guys are also working on another project, which is to replace Librarian Puppet. And they haven't officially released it yet, but I'm going to skip through the slide really quickly and you can see if you can see it or not. Okay, there you go. So there are a couple of takeaways from this talk, the core ideas that I'm trying to get at. So the first thing is that Puppet modules are a pretty neat way of separating code and sharing them between different environments. And the most important thing is to keep the feedback loops whenever you're doing your development very, very short, so that you know when the changes that you're making are failing, both for that specific customer, but across lots of different customers. And code share fundamentally is king for us. We want to enable this and make this as simple and easy as possible so that we can do the work for one customer and reshare that across all of our other environments. Hiera is the future, and you should absolutely be using it. Do you have similar problems to this? I hope that we're not alone, because I've talked about this before and other people maybe don't have these sort of problems. And how do you solve them? Thank you.
Oh, thank you, Lindsay. Any questions to him?
No questions? Oh, yep, there we go.
So do you, I mean, you saw the talk from Foreman before, so we also invested a lot of stuff in self-development. How do you, is it for you reasonable to keep the development up in your company, or do you want to rely on the communities sometime in the future?
Yeah, that's a really good question. So the question is, how do we balance all the awesome stuff that's coming out of the community in general versus developing stuff ourselves? We have an explicit policy that we don't write code unless we have to. So we try and reuse stuff from across the community, and we'll try and work with existing projects, and that's part of the reason why we were using so early on. If other tools eventually catch up to what we're trying to do, then we try and make a switch over to those. There are pretty good business reasons behind doing that. Firstly, when you hire new people, you don't have to teach them a whole bunch of weird code that they've never seen before. They probably have used that, whatever that project is. Like a good example of that is earlier this year, we built this plugin for Capistrano that basically made it work like Vagrant on EC2. And so it works, it's really cool, it works really well for us. And we knew at the same time that Mitchell was working on the stuff in Vagrant as well to do exactly the same thing. Unfortunately, we had this pressing business requirement. We had to deliver it, so we released it like internally, and it was being used like maybe a day or two before the Vagrant itself was released. So that sucks. But yeah, like we definitely want to try and use stuff from across the community. We don't want to build our own islands upon islands, I suppose. Cool. Any other questions? All right, if you're shy and you want to come up and talk, now's the time. Thank you very much.
Right. Thank you, Lindsay, for the presentation.